survey TC. Google's a data-driven company, so they like to keep track of what we Google Developer Group organizers are adding to the community. They like to see who's showing up and what kind of experience they're having. So if you have positive feedback, you want to say nice stuff, I certainly won't complain about that. But if you have constructive feedback, that'll be really great too. It'll help us make these events more valuable for you in the future. Code of conduct is on the meetup page. I think that's it.
It's linked there. It's on the main page. Code of conduct.
Yeah. I'm not going to go through this whole thing right now, but I will point this out because I care a lot about it. If at this event or any Google Developer Group event, you feel that people aren't adhering to this code of conduct, which could be summed up as be excellent to each other, please let myself or Lloyd or anyone else know, any other GDG representative. It's really important to us to provide a warm, welcoming, inclusive community. Am I missing anything? Oh, yeah, thank you. Question first.
What happened to the old Patrick?
So for those who aren't familiar, I used to have a lot of hair and facial hair, and it's all gone now. Cool. Yeah, thank you for reminding me, Lloyd. Next month, we are still looking for a speaker. So if you have interest in giving a talk, it could be a super introductory level talk. It could be super advanced on anything relating to Google technologies. Be sure to reach out to myself or Lloyd or Jeff or Valerie. We're always excited to get new voices to be a part of the local conversation. And then more long-term, not just for next month, like in coming months too. More long-term, we're starting planning already for, in February, we have one really big event called DevFest. And we'll have like 4, 5, 6 tracks. It's all day, so tons of speakers. If you have something like that you're really passionate about and you're looking to put together a nice polished talk to a really large audience, there's a great opportunity there for you and there's a lot of lead time to prepare something. So. Other than that, I don't think I have anything else from a GDG perspective. So I'm a Google Developer Group organizer, first and foremost. If I'm at a meetup, I'm here to help you in that capacity. I also happen to work here at the Nerdery, who's been kind enough to sponsor us, host us, provide the great pizza and soda and whatnot. Yeah, round of applause, please. Cool. And so at each meetup, we like to just give a moment for our sponsor to say something if they'd like. And Leah, my manager, will just say something on behalf of the Nerdery.
Thank you, Patrick. New Patrick. Yeah, I just want to welcome you guys to the Nerdery. Those of you who are new to the GDG meetups, welcome. Hopefully you enjoy our space. And we're really excited to be hosting you guys and really excited to be part of the community and supporting this community. We are also streaming to, it's kind of exciting, we have a 2-city event tonight. Our Kansas City office is also hosting the local GDG chapter there, which we're really excited about. So hi guys, hello. Yeah, and of course we're always looking for amazing talented engineers and designers and all sorts of great, talented, passionate people. And I'm going to put some people on the spot. So if you work at the Nerdery, can you raise your hand? If you want to talk to anybody who works at the Nerdery, look around. They all work here. We've got designers and engineers. If you're interested in knowing what that's like, please come talk to us. We're a very friendly group. So please enjoy. Thank you.
Thanks, Leah. Without further ado, Dan Liu.
Hello, everyone. Let me get this shut down. Uh-oh. I lost something. It doesn't matter. Hello. Oh, is everything ready? Yeah, that'd be great. I mean, if people want to be able to read the slides, that's their deal. Give me a second. Maybe I can catch another Pidgey. Your place is infested with them. Just so you know, come work at the Nerdery, and you can get so many Pidgeys for your lucky egg.
I'm not sure how to play with this thing.
So, all right. Hello and welcome, everyone. I've been developing Android for about 7 years. I'm Dan Liu. Right now I'm working for Trello. And I've given a lot of talks, and I thought it would be kind of fun to give like a very introductory talk to Android for once. So, like I said, I got into it 7 years ago, and I was kind of revisiting like how would I go about it now if I were to get into it? Because back when I got into it, it was a very different universe than what we had now. In particular, things are a lot more complex than they used to be. Back when I got into it as about Android 1.5 had come out, and there was no sense of design in it, and there were no libraries. There was just the core framework, which had about 1/10 the number of features that it has now. Whereas nowadays, I went and looked at Trello, and I listed out all the dependencies that we use and a lot of the different tools we use, and this is an incomplete list of all the stuff that we're dealing with right now. So the problem is when you start getting into Android, you might start seeing here like the 50,000 things that you need to know before you become an Android developer, and you look at a list like that, and you get extremely intimidated extremely quickly. So the goal of this talk is to talk over the air conditioner. If you're not on the stream, if you're on the stream, you're missing out on a loud air conditioner that just turned on. The goal of this talk really is to try to get some focus to this. This is aimed at people who have never done Android or have just started getting into Android. If you've done Android for 7 years, it might be kind of boring. But I also assume a little bit of development experience at least. Like if you've never programmed anything in your life, this might also go over your head a little bit. But the main thing here is just, if you want to get started with Android, where do you start focusing? And the other thing that kind of goes hand in hand with focus is that Android is like a constantly evolving platform. So not only is it hard to kind of get a grip on it because there's so many different aspects to it to focus on, the other problem is that things change over time. So if we end up putting this recording online, people watching this 6 months from now, or a year from now, or definitely 2 years from now, like some of this stuff I'm going to say is going to be wrong in the future. So it's worth noting that if you listen to this talk and then you decide to get into Android like a year from now, some of my advice may be wrong by then. Because certainly if I had taught you about Android like 5 years ago, I would have been telling you to use things like Eclipse, which no one is supposed to use anymore. All right, so getting started, before you can do Android, you have to get a few tools together. And the first thing that you really need is some sort of Android device. And for that, I really recommend that people go out and get a Google Nexus. This is in opposition to like using an emulator, because there are certainly free emulators available for doing Android development. And they definitely have their uses. But in my opinion, you really need an Android device to actually do development for it. For one thing, you just need to know how the operating system feels, just to get that basic design down. Like people who've never used Android, who are just iOS users, tend to get to Android and like look around the screen being like, okay, how do I go backwards? I don't know like how to get back to the previous screen that I was from. And it's like, Android has a button on the bottom for going backwards at any given moment. On any app, you can click it, except for Pokemon Go, because it doesn't listen to the back button for some reason. I am going to try to resist making fun of them too much. So I really recommend getting an actual Android device. And also an advantage over emulators is it gives you a real-life experience of how Android is supposed to feel. Because on the computer, you're getting this weird mixture of like superpower and like underpower. Because you're going to get superpower because you've got GPU and you've got a CPU and like could actually have like a heat sink on it, whereas this tiny little thing can only do so much by comparison to this large MacBook. So it'll give you this kind of outsized idea of certain performance characteristics, and then other performance characteristics on computers are lesser because they might have to do some emulation. And then in particular, of the Android devices, you can get any of them and develop on any Android device out there. I highly recommend the Google Nexus line because it's the official kind of branded phone of Google. And it's not actually manufactured by Google. They farm it out to a different company every year. But the main focus is that this is the phone that Google focuses on. This is kind of the ones that they develop their new operating systems on. So for example, if you've had a Google Nexus 5X or 6P, which is like the most recent phones, for the last 4 or 5 months, you could have been testing out the new version of Android, Android N. Whereas any other version, any other phone you get, you won't be able to do that. So if you're going to become a developer and you're going to get really serious about it, it's useful to have a Google Nexus. The next thing you need to get is Android Studio. And the best part about this one is it's free. So it's built on IntelliJ. That's another great thing because IntelliJ makes a great IDE. And Google's done a really good job of packaging up everything you need to get started in Android development these days. So it used to be that you have to download the Android SDK and download all of these things to your computer, and it'd be kind of confusing how you hook everything together. Now they've made it a lot better for beginners to like download Android Studio. It comes with an SDK downloader itself. It can set up an entire project for you to start. Like you can certainly do Android development in Vim if you really hate yourself, but like, and I know at least one person who does. But it's so much easier in the IDE. It gives you so many great like refactoring things. But on top of that, like there are some tools that Google is writing expressly for Android Studio, where doing it by hand is actually going to be extremely difficult. For example, they just released a new constraint layout that kind of helps, like the new way to lay out views on a screen. I'm getting ahead of myself here. But basically, it's a little bit verbose to write by hand. And they have a whole like UI editor that makes it much easier to actually do this. So Android Studio, a couple hundred megabytes, download it, install it, and use it. The third thing you want to get is a USB cable, because you're going to need to connect your device to your computer somehow. And this, like I said, this is a beginner talk. I'm going to go over everything. But in particular, one thing I want to go over, just because this is sort of a ridiculous situation. So you might have noticed if you've bought a phone recently that they have a different connector than they used to. So mine's got a USB-C connector on it, as opposed to the USB micro that are on most Android phones these days. And USB-A being that big rectangular one. So they make cords that go from USB-A to USB-C, and a lot of people make them badly. So if you are going out to buy one of these cables, I highly recommend, I think his name is Benson, he works at Google, and he just goes on Amazon and reviews all these USB-A to USB-C cables to make sure they won't destroy your computer. And I'm serious, like he stopped reviewing them for a month because like one of the cables he reviewed destroyed his computer. So if you go out and get a USB cable, be a little bit careful about it if you've got a USB-C device. And then the last step for all of this, if you want to actually do development, is you have to enable development on your phone, because it's hidden by default so that people don't accidentally start giving away all of their secrets on their phone, because when you enable developer mode, things start to get a little less safe. Google hid it in the About menu, so I made a little video of how you do it. So you go into the settings page, you go down to the About phone, and click on that. Scroll down to the bottom to where there's build number, and then you just start clicking it as hard as you can, about 10 times, maybe 7 times, I don't know. Anyways, now you're a developer, and if you back out of this, in the settings, there's now a developer options row that'll appear. And you only have to do that once, then developer options are there for all time. But what this ultimately means is now you can take your Google Nexus phone, you can start up Android Studio, you can connect the cable to the phone, and you can turn on what's known as ADB, this Android debug bridge, which kind of automatically starts up via Android Studio at the moment. And that'll actually allow your phone and your IDE to talk to each other. So those are the basic steps for getting Android development started. So now that you are an Android developer, what are you going to need to know about Android development? Do you need a data plan? No. You can do it on Wi-Fi if you want. Although I would highly recommend getting a data plan, because again, you want to simulate like real life experience. It's extremely useful to know when how frustrating your app can be if your internet connectivity is going in and out, in and out, in and out. In particular, I've been working for a long time on making our app work offline, like not have to need a constant connection to the internet, and so having a real device has been very illuminating on that. Because oftentimes if you're developing at home, where I've got wonderful USI 1 gigabit fiber, that's a little different than being out in the boonies, where you've got nothing but roaming. So a couple high-level concepts on Android of things that you'll run into on a fairly regular basis that I thought I'd just give a high-level overview of. The first thing is this idea of context. And this is a variable you're going to just see everywhere in your application. And this is basically like the environment for your phone. So it's going to be the way that you access things like metadata about your app. It's going to be where you access things like images, or where all the resources in your application are located. It's how you access things like system services. So the context You're just going to see it everywhere. It's kind of got an everything grab bag feeling to it of things that you access on Android. Second thing is a concept of life cycles. So on Android, there's a lot of provided components. So if you've ever heard of the term inversion of control, instead of you driving all of these components around, instead the components give you callbacks that you like hook into. So for example, like when you turn the phone on and I start showing the screen, it'll say like, here's a lifecycle event that says the screen, like my application has started showing on the screen. And maybe you've got a dialog on top of it. When the dialog goes away, then your app is like front and center. Then there's another callback that'll say like, oh, my application is now front and center. So a lot of the Android components that you come across are going to have these life cycles, so it's worth looking at the Android documentation and studying them. They can be a little intimidating at first because the life cycles can be rather complex, but usually most of it you don't actually have to care about. So sorry. At some point, you'll be able to suss out which parts are important and which parts aren't. But for now, just worth knowing that the life cycles exist. Intents are kind of an interesting, unique property of Android. Intents are basically the glue that keeps the system together. It's how all of Android communicates. And so if you want to launch an application, what happens is like your home launcher screen says, I've got an intent. I intend to open this application, and then that gets past your application, which then starts up. Or if you want to say like, I want to search for this particular item on Google, that's something I can pass to Google as an intent. And so intents are important for two reasons. One is that it allows you to communicate between apps, but also you end up using it a lot to communicate within your own app. So if you've got different screens on your application, you might use intents to actually navigate between them. The fourth concept that's pretty important on Android is permissions. The way that Android works is that it's like a Linux-like machine. It doesn't give you access to all of the permissions right off the bat. Like you can't just start using the camera willy-nilly. You have to declare up front that I'm going to be using a camera. So that this is sort of a security model for users, because then they might say, oh, why is my wallpaper asking for like every permission under the sun? This doesn't seem very legitimate. Don't install it. Things have changed recently now so that there's like runtime permissions, which is way better. Before you used to have to declare like I want like 20 million permissions up front. Now you can request permissions the moment you need it, which is really handy because then you can just install the application without having to ask for permission for anything at all. And then the last high-level concept I really like to kind of people to understand that a lot of people ignore right when they get started with Android is the idea of configuration. And configuration basically applies to what your phone is set up right now. So for example, this is a portrait configuration. This is a landscape configuration. My phone's currently set for English. That's another configuration. I could set it to French. That could be something else. If I plug my phone in so that it's like outputting to a TV, that's another configuration. And the reason that this is important is because Android comes with a very powerful resource system, which allows you to select resources that you're going to display based on the configuration. And if you really get a good grasp on how configuration works, it can make your life a lot easier. Because then when someone takes your phone and rotates it, you're not floundering with like, oh shoot, but I only developed for when it was like this. There are 4 basic components in Android, and the components are basically like the building blocks of your application. So these all 4 have life cycles, and all 4 of them can be used to build an application, and I would like you to ignore the bottom 3. The reason being that like a lot of the intro documentation is like, oh, there's 4 components, here's all 4 of them, and gives them all 4 in detail as if they all have equal standing. But really that one at the top is the one that's the most important. Because activities, that is the forward-facing UI of your application. That's pretty much what people think of as an application. The other 3 are much less important. Like services are if you want to run some code in the background. Broadcast receivers are just like if you want to listen to some random event that might happen on the system. And then content providers you should just ignore outright. So to go slightly more into detail on views, on activities, like I said, are the basic building block of your application. When you launch your app and it starts showing something, it's launching activity. When you use intents, you're going from activity to activity to activity. The basic building block for an activity that you need to know about are views. And what I really want to do is distinguish between views and view groups. So views are sort of like where you say you've got a button, or you've got some text, or you've got an image. Those are the basic building blocks of what your UI is going to look like. Whereas view groups determine where everything is going to be. So the view groups are usually not particularly visual. They might have a background, but that's it. So you're using a view group in order to lay everything out, and you're using views to actually put them in place. So the reason I say this is because I assume if you're going to get into Android development, the first thing you're going to do is start an activity and then start playing with the UI builder or widgets and stuff like that. This becomes important for that situation. And then on the other side of things, because this is a common early confusion, is, all right, I've got all these views set up. How do I actually do anything with them? How do I find out in code that one of them has been clicked and that now I should do something? The method you're looking for is called findViewById. You call that in the activity, you give it the ID of a view that you assigned earlier, it'll return that view for you, and then you can do whatever you want to it. And it took me an embarrassingly long amount of time to figure that out when I first got an Android. But to be fair, there was like no documentation at the time. All right, so that's some high-level concepts. Now I want to talk about what the basic structure is when you say new project in Android Studio, what are you going to give me? And I have this chart up here because I love every time that someone like gives a talk and then puts up a chart like this, because like no one's reading any of this. And no one should actually have to care about all of this all at once, especially not when they are at a beginner talk. So I put this up for my own amusement. Anyway, so there's kind of 4 components that you get when you just say new project in Android. The top component you'll see is the manifest. And this is sort of like the metadata for your application. So for example, when you click on your launcher, the manifest is where it determines what part of your application it's going to when you do that. You store things like which components you have and where. That's where you put some information about like what permissions your app's going to use. So basically any sort of like meta information that the Android operating system itself needs to know would go into the manifest. And typically when you get started, you're just going to have a single activity in it. And then as you add activities and services and whatnot, your manifest will continue to grow. I think nowadays Android Studio makes it a lot easier, so you can just like say I want a new service and it'll just start filling all that data in for you, but it's pretty well documented otherwise. In the Java directory, you have all of your lovely code. The thing that you probably know most about if you don't know anything on Android is that it runs on Java. So there's Java, you can have tests for it, you can have tests that, an interesting thing about testing Android is that when you're developing for Android, my computer actually doesn't have the Android operating system at all on it. The thing that has the Android operating system is my device. So for a lot of tests, if I wanted to test anything that depends on Android itself, the test actually gets sent out to the device to be run on this thing. Another handy reason for having a separate device. The res, or resources directory, holds, yes? What are these 3 folders? So the top one is where the actual code is going. So this is what's run on a regular basis. The one below that, that's labeled Android test. So those are tests that I can run, but they get sent out to a device first. And the one that's below that, that just says test, those are tests that don't have to be sent to the device. But the stipulation there is that those tests can't touch any part of Android whatsoever, or else they'll blow up. So for those tests are very handy for like if you just have a bunch of logic, and I would actually highly recommend when you write your Android application that anything that doesn't have to be tied into Android is not. So you just write things that are like as much pure Java as you can, because it makes it so much easier to test it so you don't have to send it out to a device. Does that answer that question? I couldn't actually see where that was being asked from, so I'm going to assume yes. Anyways, the resources directory, res for short, this is another part of the Android framework that's special to Android. This is where all the resources on your system live. So things like images that you want in your application. A lot of your layouts you will define here, so how your views are positioned. This has a mip-map folder, but that's actually just contains your app's icon in it. And it can also contain XML configuration files. It can contain the translations for all the different languages that your app happens to be in. It's kind of a catch-all for any resource that you happen to have on the system. And you'll end up using it fairly heavily throughout. And then the last part is Gradle, which is the way that Android apps are built currently. There's a few alternative build systems, but I really recommend just using Gradle at the moment, especially if you're getting started, because that's the one with by far the most support. Before Gradle, building it required Eclipse, or you could try to hack something together with Ant. And some people got it working with Maven, but it was kind of a nightmare because it was like, oh, I want to have continuous integration. I want every time I send a pull request, something to build it and test it out. That was actually very hard to set up pre-Gradle. So now that we've got Gradle, things are a lot easier. And actually, what typically happens when the IDE builds it is all it's doing is calling Gradle calls, and Gradle itself is going through the build. You probably won't need to pay too close attention to these files when you get started. The main thing that it does is just import dependencies. So when you want to have libraries, because I don't recommend writing everything from scratch, usually you go to your build.gradle files, and that's where you'll be including new libraries. There's a lot of other cool stuff you can do with it, but when you're getting started, don't worry about that. All right, libraries, things to get started with. Like I showed that, like the second slide had like an intimidating number of libraries on there. I wanted to try to focus in on just what I think is useful to know when you first get started. And the one thing that I think you should take away from this is that the Google support libraries are worth looking into. These are free, provided by Google, and they have made development, modern Android development basically possible in a couple of ways. One is that it provides backwards compatible implementations of a whole bunch of functionality on Android. So iOS has this wonderful reputation of they come out with a new version of iOS, and then everybody goes and updates, because there's only like a couple of devices, so it's much easier for everything to update. On Android, there's like thousands of devices out there. Most manufacturers want to get away with doing as little work as possible in terms of updating. So you might end up like, you might buy a phone right now that just came out today and it like never gets an operating system update for like the entire lifespan of the phone. So in that case, it becomes very important for Android developers to be able to develop for multiple versions of the operating system. And it would be a lot trickier if you didn't use any of the Google support libraries. It's split into a whole bunch of libraries. So you have to kind of look at the list of things that you're going for, but the main one that you should check out is AppCompat. And what AppCompat does is it basically kind of unifies the basic UI elements in the application. So like I said at the very beginning, when I got into this, there was like absolutely no design sensibility on Android. Then they started doing this thing called Holo, which was like sort of half design, half not. And now they've got this thing called Material Design, which actually looks good. And but the problem is if you develop an app and you don't use AppCompat, then any device that's still using Holo as its base theming, you're going to get Holo themes. And anything that you've got Material, you're going to get Material themes. And that is really difficult to work with because they do like it changes the margins and padding, and things just look completely different. There's like kind of a different language to it. If you use AppCompat, everything kind of becomes nice and backwards compatible there. The other important thing about Google support libraries is that Google's figured out that one of the big problems with the fact that Android OSs aren't updated is that new features often can't be used by developers. So Android N, that's coming out now, like sometime in the next couple of months. When that comes out, any new feature is introduced that's like for developers, you can expect to maybe use in your application like 5 years from now. So they have to plan like way in advance of like, here's some things that Android developers are going to be able to use faithfully many years in advance. And that kind of sucks. And so whenever they can do it now, basically new features are added into the Google support library. So for example, there's like a recycler view that they added and a constraint layout. And these are different ways to lay out your UI. They could have written it straight into the operating system itself. Instead, they released it as a separate library, which allows you to import it and use it like on any version of the operating system. The only unfortunate part of that is it means that like every single application on your device has have a copy of this library on it, but whatever. Another thing you're going to see fairly often mentioned, especially in Google documentation, which is probably where you're going to get started, is Google Play Services, or Firebase as they've rebranded parts of it. And these are a collection of mostly free Google services. And they do a lot of the things that you might expect to do on phones. So for example, if you want to display a map and have like navigation on there or put pins down and stuff like that's something that is not built into the operating system. That's something that Google actually provides as a service. It's a free service, but Google's the one providing it. And so there's a fair number of functionality you might think is like base Android functionality that's actually not. It's actually part of Google Play Services or Firebase. The only downside to using it is that it ties you to Google approved devices. So like the manufacturer actually has to get approval from Google before they can put this on there. The assumption, this is a way for Google to kind of strong arm companies into like actually following what they're leading. But for example, like Kindles, which do run on Android, do not have Google Play Services on them. So if you hitch your APK to Google Play Services, then you're going to be slightly limited on which Android devices you're on. The vast majority of them are Google approved, but there is that limitation there. And for the record, like every app I've worked on has used Google Play Services. So I'm not saying this is a bad thing. I'm saying it's a pretty common thing, but you should know about the drawback. And then the last set of libraries I want to tell people about, I tried to reduce this down to the minimal number of libraries, but I felt like I had to mention at least one third-party library because basically apps require the internet. Like, there aren't that many interesting applications that do not have any connectivity to the internet. And it turns out that the internet is hard to access. Like, things can get complicated very quickly, especially on Android operating system, because, again, there's many different versions of the OS. Some of them support networking a little better than others. So if you're going to be doing anything regarding the internet, which you're probably going to be doing since it's an Android phone, if you're doing HTTP, I really recommend looking into the OK HTTP library, because it makes all of this stuff so much more sane and easy to work with. And then if you're accessing a REST API, which is very, very popular these days, there's a library called Retrofit that makes it much easier to access those APIs as well. And these two like save you a bundle of work. They're made by this company called Square, which is known for making a bunch of really high quality libraries. And there's other libraries from them that I would recommend, but like I said, I'm trying to reduce the amount of like mind blowing that's going on right now. So that's it for me in terms of libraries. All right, I promise I'd talk about some rookie mistakes. So this stuff might be a little more useful for people who are just getting into Android and maybe not people who have never done Android before. But some beginner mistakes that I see fairly often that it would be nice to head off now if possible. But before that, I'm going to get a drink of water. All right, did everyone get a Pidgey? I cannot see your phone from here because of the lights, so I do not get any of these jokes that you're making about your phone. It's a flip phone? Yes. Get out. Okay, so rookie mistakes. One big first one is developing for a single screen size. And this is sort of easy to do when you have limited resources at the beginning, and you're like, I'm going to go out and buy a phone, and this is the only phone I'm going to buy, and then you're used to everything being this size. But it turns out that there's a huge array of phones out there. So there's some very small ones, there's some very large ones, there's tablets. Some phones, it makes sense for it to go in landscape sometimes. Some phones it doesn't because they're so small that whatever. But the mistake is assuming that whatever you're developing on is the only thing that you're going to be working with. And so this is where emulators can help out early on, especially with like, I don't want to go out and buy a tablet. Now I can go get a tablet-sized screen and test that everything actually works. So that's one recommendation. Like another important thing to learn fairly early on is not to think of anything on the screen as an absolute. So you're not going to think like, I'm putting a button in like 500 pixels down on the screen. You have to think of it in terms of like, I'm going to have, an image at the top and then the button's going to go underneath it. Everything's kind of relative to the size of the screen. And this may sound kind of intimidating, but it's really not so hard, especially because Android has this concept of density-independent pixels. And so this allows you to define, I want a button to be about this large, about this big, which is large enough for a finger to actually touch. You can give it a density-independent pixel value, and then you know that regardless of the device, it's going to be approximately the same size, since every device has its own knowledge of how dense the pixels are on that screen. So if you write layouts in sort of an intelligent manner, it's fairly easy to get it in many different sizes. I've actually even surprised myself sometimes where I wrote an application and then launched it on a completely different form factor, and it just magically worked because all the density independent pixels kind of scaled down, and it suddenly became just a smaller version of my application. A second problem that happens very often early on is mishandling configuration change. So I was talking earlier, my favorite configuration change is where you go from portrait to landscape. One of the things that happens very early on, so you have an activity, it shows your hello world, and you decide, oh, I'm gonna put a button on it. When someone clicks the button, it'll increase a counter, and that'll be my little demo thing. And it's working, it's great. And then you take your phone and you rotate it, and suddenly your counter goes back down to 0. And you're like, what the heck just happened? Why did it go down to 0? All of your memory got cleared. And the reason that happened is because when the configuration changes on your device, all of your activities actually get destroyed and recreated. And that sounds kind of nuts, but the reason it does it is very handy, which is that then it can do these things where you can grab resources. So if you have a different layout for portrait versus landscape, it can go recreate the activity and actually get all that correctly. But the downside means that you have to be able to store, if you want to persist data long term, you have to store it somewhere outside of the activity. A common misstep after people made that first mistake is to say, oh, I know what I'll do. I found this really cool Android manifest thing which allows me to disable rotation. Usability things aside, rotation isn't, even though it's my favorite, it isn't the only configuration change that exists. So someone can go and change their language and then go back to your application, and then you're equally screwed as before. And then the third mistake that people make around configuration change is that they'll say, okay, I'm not going to lock my phone to portrait, but I will say that I will manually handle configuration changes, because if you do that, then the activity doesn't get destroyed. But the problem is, again, there are so many different configuration changes out there, you don't want to have to manually handle all of them. And plus, by doing that, you basically get around this whole resource qualifier system that was going to be very helpful to you in the long run. So my advice is Google configuration changes. Google itself has great advice on how to handle this problem these days. At least get started from there. So a third mistake I see a lot are using implicit intents. So like I said earlier, intents are ways for everything on your phone to talk to each other, basically. And that includes if your app has multiple screens, how you launch from one screen to the next. So for example, in the Trello app, you launch, there's a home page, or there's a login screen, and then when you log in, we go from there to a home page for you, and when you click on a board, you go into a board. All of that stuff is intent to intent to intent. But there are two types of intents. And one of them is explicit and another implicit. In the explicit ones, in my application, I say something like, I would like to go from the login screen to my home screen. And I'm being very explicit about it. But some people don't realize that those exist. And then they just use implicit intents. And implicit intents are really great, because then you can say I would like someone to take a photo for me, please. So Trello does this. If you want to take a photo with Trello, you're not really taking it with Trello. We're sending you to some other application that's way better than anything we could ever do with the camera. They take the picture and then send it back to us. So that's super handy. But that means that when you use an implicit intent, it basically says anybody on the system can access this part of my application, which may be intended if you're a camera. But if your application, if you're just passing everything that way, going from point to point to point in your application implicitly, that means anyone who is malicious can create an app that also goes into your application anywhere they want to go. A fourth problem I see a lot is blocking the main thread. So Android uses a main thread, a single thread for all UI components. And the fact that it uses a single thread solves all sorts of really nasty problems that could happen with concurrency with regards to like showing the UI. So you're going to see two problems related to that. One is that you might create something on another thread and then try to manipulate the UI, and then it'll yell at you because it'll be like, you can't manipulate the UI from another thread. And there's a few constructs for getting around that. But a more important problem is that if you're doing anything that takes a while, you have to get off the main thread. You have to create a second thread in Java and go do it elsewhere. Because otherwise, if you click a button and then it does a network call, and that network call takes 10 seconds or something like that, the phone actually pops up this little dialog that says like, this app is unresponsive. This app has stopped doing anything. Would you like to just force kill it? So as bad, I mean, it's horrible in the first place. You can't do anything while you're blocking the main thread. You can't detect clicks. You can't scroll anything. But also, it makes users hate your app. So don't do that. Another one, overstuffing activity. So when you first get started, you create a new project. That new project is going to have a blank activity in it, and that's going to be like your only class so far is activity. And you're going to be tempted, I'm going to take all the logic and everything I wanted, and I'm going to stuff it into this one activity class. Don't, because that's just bad architecture. Like, you wouldn't write any Java program where everything is stuffed into one class. But for some reason, people get this sort of instinct that they need to. Remember that this is just Java with like a framework that you can build on top of. So anything that you would normally put in like different packages or like different components, nice encapsulation, you can do all of that on Android. And I highly encourage it. And in fact, activities should probably have the least amount of code as possible. They're going to get pretty full regardless, just because of the nature of how the framework works. But don't put everything in there. Put as little as you can in there. This is one I asked a bunch of friends what they thought as rookie mistakes. Oh yeah, what was the question?
You say the rule of thumb for number of lines per activity or per class for Android. I understand they can stop when information line, but
yeah, the question was, do you have a rule of thumb for number of lines in activity?
Yes.
I don't. Like I said, they can get pretty large regardless of what you do, just because depending on how complicated the activity is. And I mean, and some people write their application as a single activity and just have everything be manipulated from there because it makes animations a little bit easier. And in that case, your activity ends up huge regardless. So I wouldn't say any rule of thumb, but generally speaking, like, if you have a button and you click on it, and then the clicking of that button causes like some network request or whatever to happen, like all that network request code shouldn't be in the activity. There should just be an API that you call, like one method you call that shoots off to another part of your application that actually does all of that logic for you. So anyways, the next one, I asked a bunch of friends what they thought a rookie mistake would be, and this was my favorite one that they told me, which is forgetting the internet permission. Like I said earlier, almost all Android devices, all Android apps connect to the internet because that's what generally makes them interesting. And pre-Marshmallow, which is the current version of Android, you actually have to request permission to access the internet. And so a very classic problem that happens, even to experienced developers, is they start a new project, they get their REST API set up, and they go to click the button for the first time and nothing happens. And that's because they forgot to request permission to actually access the internet. So just remember, once you start your app, ask for permission to connect to the internet. Like I said on Marshmallow, they realized that this was so fundamental to most applications that they just granted to everyone for free. And then the last rookie mistake I would say is following Google 100%. Google has a lot of great advice out there, but they also have a lot of advice that is very tied to like the Google way of viewing things, and not all developers agree with that. There's a lot of third-party libraries that are fantastic that a lot of developers use, and for whatever reason, Google like doesn't mention them ever anywhere in their documentation. So I would definitely trust Google for most things, but I wouldn't take what they say as like gospel. So use your brain. Two ways of catching mistakes when you get started and beyond, like I still use these, that are worth knowing about. One is Android Lint, and this is another tool built into Android. Well, it's built into the Gradle build system, but you can get to it through Android Studio. And this will scan all of your code, so all of your Java code and all of your resources and your manifest and even your build Gradle file, I think, and it'll look for common mistakes that can be made in code. And if you start using Android Lint early on, it'll be really handy because it'll point out to you a bunch of little mistakes that a lot of developers have made over the years, and you can correct them then and there. If you wait until you're like 2 months into a project and then you run Android Lint, you're going to see like 1,000 things, and you're going to get overwhelmed very quickly. So I recommend like trying this out as early as possible when you get started developing. But again, don't take everything it says as gospel, but most of it's correct. And the other thing worth looking into is a strict mode. Strict mode, you turn it on, and it can purposefully disable or enforce certain things in the application. So for example, like I was mentioning earlier, you don't want to block the main thread doing anything that takes a long time or an indeterminate amount of time, like accessing the network. And with strict mode, if you turn it on, you can say, I would like you to like flash the screen red every time that I try to access the network on the main thread. So it can be a little overbearing and annoying, but it's useful when you get started and you don't have like a great grasp on like how to move within the correct bounds of an application if you turn this on. All right, a first release checklist. I'm putting this up because this is once you've got your Android app done and you'd like to release it, but there's a few things that you really should pay attention to before you release, because there are some things that you cannot change, or there's some things that you should not change. But there's definitely some things you can never change, and so it's worth having at least one brief check through this. So the first thing you can never change is the package name. So every Android application has a package name. So for example, Trello's package name is com.trello. Most of my applications are net.danlu. Whatever the application's called. This package name that you pick, that's it forever. So if you're going to develop an app for a company, maybe don't have the package name be something silly or have a swear word in it or something like that. Like, have it be com.company.whatever. I remember iOS when one of my friends who got me into mobile development first got into it. He didn't have a company. He just released his app under Ben Kazez. And then this app did extremely well, but he couldn't change the company name without like some serious repercussions. And so for years, like one of the best-selling travel apps was delivered by Ben Kazez, even though there was an actual company behind it by that point. One piece of advice, if you're working on an Android app for a while, is that you can create a listing on the Google Play Store. So the Google Play Store is where all of the APKs live that get uploaded and actually are what's downloaded to your phone when you go to get it. When you actually go there, you can create a listing ahead of time, and you can basically claim your package name ahead of time. Because otherwise, if you upload like an early version of your APK to the internet, but not Google Play Store, someone could grab that APK and upload it themselves to Google Play Store, and then you're forced to change your package name because they got to it first. The second thing that really can never change is the signing certificate. So all APKs are signed with a private key that allows you to, that basically is using certification in order to tell this Android operating system that yes, this application is the one that I told you about. So this is important for upgrades. So if I install version 1.0 of Trello, and then suddenly this APK comes along and says, I'm version 1.1, it can't be just any stranger installing 1.1. Like, the APK actually has to match signatures before it'll do the upgrade. And so the signing certificate's important to get right. Have it be nice and secure. Google will force you to make a nice and secure one these days. That used to be a little more loosey-goosey before. But the super duper important thing is to not lose this. Because if you lose this, you can't publish any updates to your application. And companies have lost them before. And it's embarrassing because they might have hundreds of thousands or millions of users, and they have to go tell all their users, go download this new version of the application. And you lose a whole bunch of users that way because a lot of users stick around solely because of momentum. The last thing, you can change your manifest API. Like I said, your manifest is like the metadata about your Android application. You can certainly change this, but the manifest should be viewed as if it's like an API, like a public-facing API. So for example, like I'm telling, when I have a launcher and people like drag that to their home screen or something, that's my manifest saying, here's where to start my application. And if you go and change that around, no one will know how to get to your application anymore. You'll end up with the home screen saying there used to be a launcher here, but I've lost it and I have no idea where it's gone now. So in general, the manifest you have to be a little careful about. There are some things that can change, but I highly recommend having them in the first version of your application, the crash logger being one of them. There is not built-in crash logging on Android, not good built-in crash logging, and before you first release your app, it's really handy to have a service like Crashlytics or BugSense or Firebase Crash. There's a bunch of free services and some paid ones that basically when your app crashes, it collects the stack trace and tells you all about it. And this is so important. Everyone uses this. But you especially want it when you first release and you don't know what you're doing on Android, because then you'll find all sorts of crashes you had never anticipated happening. And then the last thing is a publishing Google account. If you're publishing an app for a company, I highly recommend buying a separate Google account to actually publish under. The reason being that if you're just using your personal Google account and something happens dramatic to your personal Google account, that could affect other things in your Google world. So better to kind of dodge all of that and just keep everything separate. All right, so I blazed through a whole bunch of random concepts, but clearly this isn't enough to actually get started on Android. So I wanted to go over some resources that I think are particularly useful in terms of continuing education if you want to really get into this seriously. Java, if you don't know enough about Java, I recommend the internet. It has a lot of really cool stuff about Java. Honestly, it's been so long since I did an intro to Java course that nothing I learned from there is relevant nowadays. So I don't know what an intro to Java book would be that's particularly useful. But there are two books that I think are useful when you know a bit of Java. And one was Head First Design Patterns, was a really handy book. It has a really stupid cover, but what's inside is pretty nice, which kind of goes through basic design patterns in Java specifically. And then once you've got a bit more experience, I highly recommend getting Effective Java, which has all this great advice on how to properly code in Java, good patterns from bad patterns. All right, learning more about Android. I also recommend the internet. The internet is just a great resource for computer stuff in general.
Is that because it runs it?
Is that because it runs it? I think so, yeah, because the internet's run by programmers and they like hanging out on the internet and actually putting stuff up for free. The official Android documentation is great. I've heard a lot of people bash it over the years, but honestly, I feel like they have never experienced really bad documentation. Most of the Android docs actually have words in them versus just being method names that don't make any sense. And Google's really gone above and beyond trying to have not just API documentation, but actual training involved. There's a huge amount of stuff you can read, almost too much at this point. But I highly recommend just looking at the Android documentation first. If you want to get an Android book, my recommendation would be the Busy Coder's Guide to Android Development. And that's because this isn't quite a book. It's actually kind of a living document. Made by Commonsware or Mark Murphy. He basically has written a book that lives on the internet, and that means that he can keep updating it as things change in Android. So like I said, Android's constantly evolving. If you buy a book off the shelf, it will probably be out of date at the time you bought it. There was actually a friend of mine who wrote a book about Android tools and IDEs, and he wrote all this stuff about Eclipse, and then 1 month later they announced Android Studio, and bye-bye. That's too bad. So if you're going to spend any money on a book, I would highly suggest, because this guy is smart, and I'm not getting paid for pushing this at all, so useful stuff. If you want to do actual training, there's a set of official training courses that Google set up in conjunction with Udacity. And I believe you can take those for free. If you pay some money, then you get some bonuses, but for the most part, it's free. In conjunction with that, there are Google Study Jams that local GDGs, such as this one, run. And I believe you run it once a year around February-ish. Are you going to continue doing that? All right, so yeah, if you want to get into this about 6 months from now, you could look at the Google Study Jam. That's cool because then they meet up every week and go through. Do you go through the Udacity course? Yeah, so you go through the Udacity course, you have people you can talk to. It's a really good program. And then on top of that, there's all sorts of paid training services you can do. My understanding is that Nerdery has one, I think. I don't know, I was Googling around on the internet. There's that, there's like General Assembly, there's Big Nerd Ranch, but there's all sorts of consulting companies that will certainly, if you pay them a lot of money, will make you an Android expert as quickly as possible. And then the last thing that you really want to check out and really want to take advantage of is open source software. Because Android itself is open source, and a lot of the people who develop for Android write open source libraries. It's really big in the culture, and that's fabulous. Because this means that you get to look at all of this stuff for free and learn from it. Like a lot of the early stuff I learned from Android was just seeing applications on my phone and then going and looking up the source code for them. So the first one to look at is the Android open source project. And that's where the actual Android sources are located. It can be a little intimidating to download them, but once you get it, it's super great because you can look at what's actually happening in the operating system. And it makes debugging so much simpler because you can be like, why did this method call not work? Oh, you can actually sort of trace it through the code and find out where everything blew up. And actually, they don't release the source of each operating system until it actually comes out. And so Android N, which has been in development for a few months and I've been working on supporting in our app, like I've had some hair-pulling moments where like I couldn't look into the source code and was like, this is what it's like to be an iOS developer. Some cool projects to check out. Jake Wharton is like the superhero of open source, and he has so many projects. But in particular, U2020 is a particularly complicated Android application, but it's just a sample. And it's designed to show off a whole bunch of aspects of Android and different open source libraries you can use in it. So that's a fun one to study, and I still look back on that every once in a while for reference. Google puts out some official open source applications, probably the most notable one being IOShed, or Schedule. It's the schedule app that they use at Google I/O, and every year they open source it like a few months after Google I/O is held. So that shows a lot of the things that Google likes to do in terms of Android development. Again, don't take everything as gospel, but very handy. But there's that, and there's just so much more. I thought about listing all the ones that I found that looked pretty good, but it seemed like there was going to be an intimidating number of apps. But there's a lot of open source apps, and if you want to learn by example, it's out there. All right, that's about it. Stack Exchange for like question and answer?
Yes.
Yeah, it's super valuable. But that's like a given in any language. I mean, I would, if you don't know about Stack Overflow, that's a programming question and answer site that everyone should know exists, because anytime you type into Google a question, it comes up with Stack Overflow. So it's kind of hard to not know it exists. I put a link up to the slides because a lot of this stuff is just like bullet points that might be useful to reference later. But I thought I'd open this up for questions for however long we've got. If anyone wants to know about how to get into Google, and there's apparently a thing here too. Oh, nope, they haven't said anything. All right, any questions?
What advice would you offer a beginner about debugging?
What advice would I give to a beginner about debugging? Do you mean, in what aspect do you mean?
In the aspect of figuring out why my app doesn't work like this.
Sure. Okay. So there's two general things I'd advise. One is that you can there is a debugger built into Android Studio, so you can attach it to a particular process and then set breakpoints as you would normally for running through a program and looking at variables and stuff like that. So that's very handy. Step one. Step two. And I had thought long and hard about including these slides, but I chose not to, and maybe now I'm regretting it. But another really cool library that you can check out is called Stetho. And this is a library, an open source library from Facebook. And it is this like mega tool that basically allows you to like hook into your application and read a bunch of data that would normally be hard to get out. So for example, if you're writing to a database, it would normally be a little tricky to actually like just get a simple table view that's seeing what's in your database right now. Whereas with Stetho, you can load it up and you can look at it right there. Or if you can hook it into your network calls, and then you can actually see like which network calls are going in and out, what sort of responses are happening, what headers are being passed back and forth. If you've ever used Chrome's like inspect element or like that whole developer tools, it's actually built on top of that. So a lot of the things you get from Chrome's developer tools are equivalent things you get on Android. So I'd highly recommend checking out Stetho as well for like debugging issues. Anything else?
Will you be posting that link to the meetup list?
The survey or?
Slides.
I'm not sure what you're asking. Which slides? These slides?
The one behind you on the screen. Already done. Will you be posting that link to the?
Am I going to post that link right there?
Yes. Already done. Thank you.
Sorry, yeah, I don't run the actual GDG, so I'm not in charge of that.
So my question is, sometimes when you look at somebody's else application, you are debugging it, and you try to figure out the structure of variable. And you expanded all its array. You expand an element of array, oh, it's actually a list. You expanded it's again an array. And it feels like infinite the size of the variable. Is there a good tool to analyze variable structure?
Is there a good tool to analyze variable structure? I generally don't have that problem. The only thing I'm thinking of off the top of my head is the memory analyzer tool. The memory analyzer tool is mostly useful for looking up where memory leaks are happening. So that can be useful if you're like trying to figure out, of these like thousands of variables I have right now, which one actually is holding on to the GC root and causing all of this memory to leak. But in terms of more complicated structure, I usually don't run into that problem. Usually the variable itself is fine. What I sometimes do is write a toString method, which then gives me like a very summarized version of that like variable, so I don't have to like actually trace through it. I can just very quickly get to it. And in fact, you can have the debugger, the breakpoint, instead of the breakpoint pausing, you can set it up so that the breakpoint like spits out what the toString of some particular method is. So that can be really handy for debugging as well.
We got a question from Kansas. What are your favorite things about Android N?
What are my favorite things about Android N? I can't remember much about Android N, to be honest. Probably the split screen, because the split screen's the big feature, the one that I had to deal with the most in terms of fixing our application. But it just, before only a single application could run at a time, now you can have two applications running side by side. And that's really handy. Like I got a bug report that the Trello login screen wasn't working that great. Like it's set up to look pretty, but when you make split screen, it's going to be really small, and then the layout looked really awkward. And I thought, oh, whatever, I'll just ignore this, because how much of the time do people really spend on the login screen of the application? And then I realized that's the one time when split screen would be really handy, so that you can like copy and paste your password out of one application and paste it into the login screen on another. So I was like, oh, I better fix this. But yeah, that's the big thing that comes to mind for Android N. Anything else? Yes.
New to Android development, can you write an app about using fragments?
Can I write an app about using fragments? Or can I talk about using fragments?
Well, I mean, you're talking about rookie mistakes. Can a person, like, say, ignore fragments and develop an app that way? Is that advised?
Okay, so fragments are a big point of contention in the Android community. Some background, like I said, the activity is like the base part of how your UI is structured, and then you use views in order to like actually put widgets on the screen. Fragments sort of live in between the two of them, and were introduced like partway through the Android framework life cycle, like Android framework development. And so fragments themselves have their own life cycle, so they're kind of like bits and chunks of logic and views that you can port to different parts of your application. The thing is that they are fairly complicated, and they had some nasty problems with them for many, many years, and so some people have sworn off fragments altogether. Personally, I don't really care. I use fragments. I think they're handy for certain things like dialogues especially, and also I haven't really been bitten by them as much as some other people have, I guess. So I don't have like a strong opinion on fragments. If you want to develop your app without fragments, you can certainly do that, and plenty of people have. But I think fragments can be handy, especially in the dialogue case, because in the dialogue case, it really is just this little thing that you want to survive rotation, and one of the things that fragments do nicely is survive rotation, or configuration change in general.
What does the backend
What does a back-end developer need to know about Android?
Yes.
What are you trying to do?
Just data processing and that stuff.
I guess if you're developing the back end of an Android application, it's really not that much different from developing the back end of like a server, honestly. Like I mentioned earlier, the last year I've been working on making the app work offline, and so a lot of that is just back end work, and I sort of feel like I've like become a server dev again, because I so rarely like dip into layouts and changing that sort of thing.
Developing an app that is running real-time sensor data processing, is Java and the framework going to work?
So if you're developing an app that has real-time sensors, is Java and the framework going to work? Definitely, sure.
Is enough performance there to deal with the latency and low latency processing?
So that gets into an area of Android that I haven't really delved into myself, because I haven't. I know that for years there was like problems with audio latency, kind of like on an operating system level. But I've never actually developed something that was like so dependent on real-time sensors. In terms of like general sensor usage, it's certainly fast enough. So for example, one application, I had a cute little animation that like depended on whatever the gravity was right now. So it'd be like a little plane ride, and if you tilted your phone, then the screen would kind of tilt in different ways. So it didn't have any trouble like grabbing that sensor on a regular basis for that. But if you're talking about like analyzing audio or like manipulating audio right as it's processing through, I don't really know too much about that. So I don't know. I think they've been working on it for the most recent versions of Android, like trying to make that a better situation. And on Android, that's good. What's worth mentioning on Android, you can jump out of Java, you can jump out of the framework and just write your own pure C code if you want. But then you're losing a lot of the advantages you get from Android. And I think there's a misconception that if you go down to C, it's going to be a lot faster. It's not necessarily the case, especially because you're jumping through the JNI layer, and jumping back and forth between that can like take a lot of processing power. So like whatever you gained using C, you might lose in that transition. So most of the people who do things like C are doing things like, I guess, audio processing, but also a lot of video games are actually written in that. So.
Another question, what success have you seen from the Udacity course?
What success have I seen from the Udacity course? I haven't seen any just because I don't know anyone who's gone through it personally. Because most of the people I hang out with are people who like already have gotten past that stage. So unfortunately, I don't have like an honest answer for that. Maybe Patrick could answer better since you ran the Google Study Jams.
Sure, yeah.
Wait. So the person asked the question.
Sure. Yeah, I've seen mixed results. A lot of it depends on how much time you have to devote. So a lot of people are pretty busy. It does take a fair amount of time to get your feet under you. But I'd say probably 25 to 50% of people, and that's including people that just didn't realize the time commitment up front. So.
There you go. Definitely. So I would say, so there's two great podcasts out there. One is Android Developers Backstage, and that's an official like Google podcast. And that one's cool because they tend to hit like all the major topics, and then they talk to the people who actually develop those things. So like, for example, I just finished listening to an episode they had about constraint layout, which is something they announced just a couple months ago, and they talked to the three people who actually like wrote it. So that one's really nice. The Fragmented podcast is really nice. That's kind of like run by a couple friends of mine. That makes it sound much more podunk than it really is. It really is also highly respected, and they talk a lot more about like open source libraries and other aspects that just like Android Developer Backstage doesn't get to. And then in terms of keeping up with like blogs and everything in general, what I'd recommend getting into it first is there's a weekly newsletter called Android Weekly, and that I highly recommend. It's always got it's a cultivated list of links to read about Android and things adjacent to Android. And it's also got like job postings on it. It links to videos and it links to podcasts. So if there's only one place you want to go, I would suggest Android Weekly because it'll kind of get you set up for keeping your finger on the pulse. Sorry, I just have to apologize because there's that light right there. So from this angle, if I don't go like this, I can't actually see anyone over there. Okay, so the question is, if you're a beginner, how would you get started with an app that like connects to a server, basically? If I was an absolute beginner, well, I guess it depends. Do you have like a particular app in mind you're trying to work on, or do you just want to like learn how to connect to servers? Okay, so you got a particular app in mind. I guess you could just do everything at once and see how that goes. If you want to do it in a slightly more structured fashion, there are plenty of APIs public APIs out there that you could like write an Android app for and then test, like learn how you connect your Android phone to those APIs and see how well that works. So for example, a favorite one of mine is that Marvel has an API where you can like query all this information about superheroes and supervillains and stuff like that. And that one's public and free. You just have to sign up for an account and you get access to it. And so you could like write an Android app that just, you enter some text and it searches the database, their database for it, and then displays it on the screen. And then you can get an idea for how Android works networking-wise. And then from that, maybe you could write the server to actually connect to. That's part of the reason why REST is so popular right now, though, because it makes it very easy for like an Android app to actually connect to the internet. Because there's kind of like, that one just uses HTTP calls to like communicate back and forth, whereas other applications might decide to do something much more complicated. So for example, Pokemon Go is built on top of, sorry, I got it on the mind. But it actually is a good example. They use something called Google Protocol buffers, and that one, and just remote procedure calls. So they're just connecting to some, well, they're also connecting over HTTP, I believe, but then they're just sending this like super compressed data format back and forth, which is kind of complicated. Whereas if you use a REST API with JSON, it gets a lot simpler to work with, which is what the Marvel API is, I believe.
What's your opinion on third-party software that allow you to develop and deploy cross-platform to Android and iOS, like Xamarin, for example, is pretty huge?
So yeah, what do I think about like the third-party software that lets you write for iOS and Android all at once? Like Xamarin, like Unity. Well, Unity, I think Unity is great because game development is something I've never done, and I assume it's doing a great job. In terms of Xamarin and whatnot, but the part of the problem is that I've never actually worked in it, disclaimer first, but part of the problem is that so I do Android development full time, and I feel like I can barely get enough performance and like know-how of the system to like do what I want to do on a phone. And so imagine now you've gotten like another layer of abstraction on top of that. So it can be hard to get down to like the level of customization you want. And typically apps that are written on those like multi-platform things just don't feel quite as good as the ones that are written purely native. That might be a little self-serving because I am an Android developer and not like a Xamarin developer. I understand that. But I really do think that like if you're writing like a little internal application for your company of like 100,000 people or something like that, Xamarin can be useful then because then you only need fewer devs and you don't need the user experience to be like something that wows the customer because they're going to use it whether they like it or not because they work at your company. Whereas if you're like trying to bust out onto the scene and becomes the next Snapchat or something, probably is not as great to use something like that. In that case, I would probably just focus on one platform or the other to start. And then once you've proven that you've actually got a successful model, then you can start hiring someone to do native development on every platform. And there's been a number of people who've tried to write multi-platform solutions and gotten very far in it and then written blog posts and gotten up and given talks about how great everything is, and then they give up a couple years later. Facebook did that. And when they did that in like 2011, 2012, everyone's bosses was coming to them and saying, can't we be like Facebook? can't we just have the web on our devices and then it'll be so much easier? And then Facebook like gave up because they were tired of people making fun of how slow their app was. So anyways, that's my general thought on it, is that native, you sort of need to get so close to the gears already to get the performance that like it's good to do native. Anything else? If not, I'll be around, and also I tend to come to this meetup, so you can bother me in future months. Thank you very much.
Thanks everyone for coming. Feel free to mingle. If there's any pizza, help us finish that up. Gonna try and start heading out around 8 o'clock. That way the fine folks who are volunteering, helping out with the space, they can get cleaned up and get home to their families. One last time, want to plug the survey. The link is on the meetup.com event, the meetup.com page for this event. So thanks again everyone for coming. Hope to see you again at a meetup soon.